Hi everyone, I'm Bailey Montgomery and welcome to my quick little crash course on those giant space vacuums, black holes. Let's get started. So what is a black hole? A good definition of a black hole is a region of space having a gravitational field that no matter or radiation can escape. Not even light is fast enough to escape the gravity of a black hole. You'll notice on the outside of the black hole, there's a small ring of light. That is called the event horizon, or the point of no return. Anything that crosses over the event horizon will have no ability to escape the forces of the black hole. In the very center of the black hole is what's called singularity, or the point where all matter is crushed into an infinitely small bundle of energy. A good way to think about how a black hole works is comparing it to a waterfall. The fabric of space is falling into the black hole just like water falls over the edge of a cliff. Now say that in this 360-degree waterfall we had two little fishes. One fish can swim just fast enough that he doesn't fall over the edge of the waterfall, but not fast enough that he can escape its current. The other fish cannot swim fast enough and goes over the edge of the waterfall. The fish at the top of the waterfall, though, swimming his hardest, will never move an inch because the speed of the water cancels out his movement. The same thing happens with black holes and light photons. Any light that crosses over the event horizon will be sucked into the black hole and crushed. But a light photon that gets trapped in the event horizon, like our little fish here, will remain there forever, traveling the speed of light. These light photons help to create the little glow around the event horizon. How do we find black holes? Scientists can spot black holes by observing the stars. If it appears that several stars are orbiting around seemingly empty space, there's a good chance that a black hole is at their center. There are two types of black holes. Stellar black holes are smaller and more common, and supermassive black holes, which can be millions or billion times bigger than our solar system's sun, and they're found at the center of galaxies. The term for what happens to matter is when it's swallowed by a black hole is called spaghettification. Though it may be a funny word, it's a good descriptor for the process. Spaghettification is the theoretical stretching of an object as it enters a black hole. As you can see here, our stick figure, who would otherwise be normally sized, is stretched out like spaghetti by the intense force of the black hole's gravity. As matter reaches singularity, it is crushed into an infinite ball of energy. Not to worry though, the process is so quick that if a person fell into a black hole, they wouldn't even feel a thing. The good news is that black holes do not really pose a threat to us on Earth, at least not at the moment. Stellar black holes have such a small radius that a direct hit with Earth would be very unlikely. As far as supermassive black holes go, they don't travel around the same way that stellar black holes do. They stay in one place, which is usually at the center of large galaxies, holding it all together with its gravity. So the next time you're tempted to be afraid of black holes, you might try being thankful for them. After all, a supermassive black hole is at the center of our very own galaxy, and is the glue holding us together. So that's it. There's so much more information about black holes, but hopefully you learned a lot about the basics here for just a few minutes with me. I will see you later.